Hey everyone, good evening. I'm Adarsh. I'm the co-founder and lead consultant at Digio Labs. At Digio Labs, we provide Python and software development consultancy to our global clients to turn their ideas to reality using technology. So today, we'll be attacking Pygoat, an intentionally vulnerable web application written in Django, and we will learn Django security the hard way. So let's start by looking at what web application security is. So it consists of a set of measures or approaches which are aimed at safeguarding servers, applications, APIs, etc. Now let's take a look at some of the stats. An average website experience like 172 attacks every day, and the volume of attacks against applications are doubling year over year. So for businesses, these attacks leads to loss of credibility. They can lead to financial losses, and this can lead to compromise of user data. And for us users, it can lead to the compromise of our personal information and something like our order history, our addresses, and in some worst cases, it can lead to like password breaches or breach of credit card information. So this is a site haveibeenpawned.com. This was created by a security researcher where we can input our email ID and check if our data was involved in any breaches. So this is the result for my personal email ID. My data was breached in 4 data breaches, and I think currently there are multiple vulnerabilities being updated every day, and if you are checking, I'm sure if you have been using internet for the long time, at least your data will be compromised in some of these breaches. So that's the current scenario. Due to this, we should ensure that our applications are secure. For building web applications, like there are a lot of resources available. We have lots of tutorials, learning paths, but there is relatively very less guidance and resources for building secure applications. And due to this, security is often learned the hard way. For this, we have OWASP. OWASP stands for Open Worldwide Application Security Project. So they are an online community. They produce freely available articles, documentation, tools, and resources so that we can test as well as fortify our web applications. Then OWASP regularly publishes a list of vulnerabilities, top 10 vulnerabilities, which are the most commonly seen in web applications. So the current version is the 2021 version of OWASP top 10. These are the top 10 vulnerabilities. Now, coming to Python and Django, we have Pygoat. Pygoat is an intentionally vulnerable Python Django app, which can help us learn about security. And Pygoat contains multiple labs, which are like intentionally insecure applications, so that we can exploit and learn about these OWASP top 10 vulnerabilities. So in this talk, we will be going over a few of these with a demo. So let's start with the third one in the top 10. It's injection. So injection happens when an attacker sneaks in untrusted data. So it will allow them to run unintended commands, or it allows them to access unauthorized data. Some examples include SQL injection and command injection. So we have our lab one. In this lab one, our mission is to get unauthorized access as an admin. So this is the setup instructions. It's like just another Django application. We can install the requirements, then perform migrations and run our server for running the Pygoat. So for the injection, we have our first lab. I am running my Pygoat application here. Now let's take a look at the first lab, which is SQL injection. So our mission is to log in as an admin. So let's try the username is admin, and we can try to enter any random password. So we are getting the error that the password doesn't match. Now let's go back and take a look into the code. So this is the source code of the query. So the application gets username and password from the request, and it just executes. It builds an SQL query, and then it just executes the query. So this is the SQL query. And if the executed query consists of a result, we will log in that user. Otherwise, we will return a result. Let's see what is the vulnerability here. This is the SQL query we have seen. Suppose the username is John and the password is pass1. We are using string concatenation to add name and password to this row SQL query. So this will be the generated query if we enter these values as the username and password. Now let's move to the vulnerable section. What if we enter the password as this string? This is a specially crafted SQL injection string. This is one of the basic SQL injection string. We have like multiple combinations and type of SQL injection. So let's try this basic one. So we can see the password will be replaced with this specific string, and this will be the generated SQL query. So we can see an OR condition is being injected here due to this string we have entered in the password field. So this OR condition checks for 1 equal to 1. So that's always true. So our password check will be skipped in this section, and the user John will be logged in if you are entering the username as John. Now let's try that here. This is the password I'm going to paste here. So yeah, we cracked the lab. We could log in as admin. So this is the first vulnerability. This was the vulnerable code here. The row SQL statement was constructed based on the user provided input. Next, we have like similar another similar range of vulnerability. This is for shell injection. Let's go through that a bit fast. This is our lab 2 consists of an application for name server DNS lookups. Let's see its code. This is the code of the application. So it gets a domain name from the input from the post request, and it executes either nslookup command or dig command using the domain provided by the user in the input. And it just returns the output to the user. So the command which was given by the user is executed using subprocess.popen. So it executes a shell command in the server system. Let's see what happens in the lab. So first I am giving a domain name, and I am adding one more command together with that. So I have added the dir command. This is to perform a directory listing. So we can see I am getting the output of the command, and my working directory of the server is listed here. Similarly, I can inject any other command, like maybe I can run some arbitrary code, or I can dump the env variables on the server using this injection. So to prevent these kind of errors, one thing is we should use a safe API. Like in case of SQL, we can use parameterized queries. Then we should also do a server-side validation of the user-provided inputs, and we should escape the special characters provided by the users. Coming to the Django-specific mitigation steps, if you are using Django ORM, the Django ORM operations prevent SQLi vulnerability. So we should avoid using raw queries. when possible and use Django ORM. Next, we have one more vulnerability in the injection section, which is XSS. And when we are using Django templates, it has built-in protection against most of these XSS attacks. And regarding other command or code execution vulnerabilities, we should not directly take input from the user and execute OS root system subprocess or eval like commands from these user supplied inputs. Next, in the OWASP Prop 10 is A5 security misconfiguration. So these type of vulnerabilities occur because our application misses some security hardening, and there might be some unnecessary features which might be enabled due to the presence of some default accounts and all. Let's move to a lab one. Here, our goal is to get a secret key. When I am trying to get the secret key, I'm getting an error message. Only admin localhost port 8000 can access. Your X host is none. So since this is an intentionally vulnerable application, the error is directly pointed for us. Let's look at the code. The server just checks if a header is present, and based on that, it's authenticating the user. So to attack these kinds of things, we can use an intercepting proxy. So this is a tool used by security researchers. There are tools like OWASP SAP or burp suite. You might have used the network tab in the developer tools. So similar to that, we have some tools used by security researchers, so we can modify the requests, we can perform some attacks and all. So for this specific thing, I am using a tool called SAP. It's an open source application by OWASP. So I am currently intercepting the request sent by browser, and this will be intercepted by the SAP application. So I am turning on the proxy in the SAP. Here, the request I have just sent is intercepted by SAP, and I can add the requested header here. So you can see that by adding or injecting the header, we got successfully access to the secret. So this is an example using another tool. It's called burp suite. Here we are injecting the same header, and we will get access to the secret key. Now the case here is like an example of security through obscurity. So in our case, the application trusts raw inputs from the front end. So we are just checking the value of a header which can be edited by the front end. So predictable or front end supplied values should not be trusted for authentication. And maybe you can think that this is an oversimplified example. Let's take a look at a security misconfiguration vulnerability in the real world. It's a bug which was found by Arun Suresh Kumar in Facebook. So this allowed any attacker to delete any Facebook page. So an attacker could intercept the request to delete his own page, and they could just change the ID of the page to the target page ID, which accepted like any public Facebook page, and we could have deleted any pages from the Facebook. So in that case, users' permission to manage the page was not checked in the backend by Facebook, and this was patched by them properly. Next, our mission in this lab is to get a secret env variable. So this one is due to a misconfiguration, like we have our application deployed to the public, but we are keeping Django debug mode as true. So we can see the 404 page here lists every possible endpoint. Now we can see there is a 500 error page. I am going to that page. This is an error page generated by Django. So here, all our application env variables, settings variables are listed here. And we can see a sensitive data is being exposed here. So this is the goal of this lab. Whenever our Django debug mode is enabled, whether if an attacker was able to like trigger a 500 error, maybe they can try with some other request parameters, or they can try various things to generate a 500 error, and then our settings.py data will be dumped and they will get access to some sensitive data. So to mitigate this, whenever we are deploying our Django application to a publicly accessible environment, we should disable the debug mode. Next, for preventing security misconfiguration in general, we should have a repeatable hardening process, and we should remove unused features. We should have like processes in place to manage vulnerabilities. We should always review our cloud storage like permissions, example like the S3 bucket access permissions, etc. Next is A6, vulnerable and outdated components. So the previous things, like they concerned about the code we write, but if we are using any other vulnerable or outdated dependencies, these can also lead to some security bugs in our code. So in this lab, our mission is to execute arbitrary code on the server. Let's see the lab. So this lab is a simple YAML to JSON converter. It will allow us to upload a YAML file and it will convert that to JSON and give the output. Let's take a look at the code. There is nothing much here. We are just using the YAML load from the PyYAML library. We are using the library PyYAML as our dependency, but the version we are using has a vulnerability. We are using an outdated version which has code injection vulnerability. Let's see what happens. We have two YAML files. This one is a safe YAML file. So here we can see the YAML is converted to JSON and we have got the output. Then let's take a look at the evil file. So this is a specially crafted YAML and this will execute this Python statement on our server. Let's try that. Here the output is none, but let's check our Django output, Django terminal output. You can see the statement is printed here. So we can add any command here, like we can use os.system to run system commands. We can get the env variables. We can run any code in the server using this exploit. So in our case, the issue was caused due to an outdated or vulnerable version of PyYAML. So we should remove unused dependencies. Then we should continuously monitor all the dependencies used and their related vulnerability information. And we should always verify if these are obtained from secure links from official sources. Next, we have identification and authentication failures. So these occur when we have like some mistake in the way we do password validation or user logins and all. Next, in this lab, our objective is to log in as the admin. So this is our code. Our mission is to log in as admin. Let's try something. Let's also try maybe the SQL injection string, but that will also not work here. But we have another option called login with OTP. We can add our email address here, and it will send an OTP, and we can try to log in using that OTP. So it's displaying a message that our three-digit verification code is sent to our mail ID. So the one option is the real admin would have received an email with the OTP, but the OTP just have like 3 digits, and the combination can be from 100 to 999. So there is only a possibility of total of 900 possible OTPs. So we can try sending 900 requests and check if we would get access. So this is the code. Initially, an OTP is sent. Next, from the post request received, it will check the OTP and email, and it just scans the database. There are no captcha or like rate limits enforced. So we can try to brute force the same. So I'm using the same tool. I'm using SAP to intercept the request. I'm starting with 100 as the OTP. So you can see our OTP request here. This is the request for the OTP I have sent. Here the body contains the OTP value as 100. Next, we will be using a tool provided by SAP to do that. Let's attack that and use the tool called fuzzer. Inside the fuzzer, I can specify that I need to try out this OTP with numbers starting with 100 up to 999. So SAP will automate the entire process of fuzzing, and it will try out the same endpoint with all these generated inputs from 100 to 999. So let's try out that. So it's being executed. Okay, to identify whether we have logged in correctly, let's sort this by size of the response body. So all the remaining requests have this size, and one have a slightly different size. This is when the payload or the OTP was 653. Let's inspect that. So this is the request. We have sent the OTP as 653. Let's take a look at the response in that case. You can see that the login is successful in this case. The attacker could log in as admin as pygoat.com. So we exploit a lack of rate limiting feature in this OTP verification flow. To mitigate these kind of vulnerabilities, we should, when possible, implement multi-factor authentication. We should avoid default credentials, and we should try to delay the failed login attempts. Next, before ending this, let's see a real-world example of this. So this vulnerability also happened with Facebook. So Facebook had a vulnerability that could let an attacker take over any other user's account. So they had a 6-digit password recovery code. The rate limiting was enforced on facebook.com, the domain facebook.com. So after like 10 or 20 attempts, the user will be blocked from further attempts. But the rate limit was not enforced on beta.facebook.com domain. So using this domain, an attacker could like try all the possible combinations to brute force and get access to a user account. So these are the references I have used for this talk. You can use the Pygoat project, or this is a fork where I have added these documentation README files, and I have fixed a few dependency issues. Next, if you're new to web security and if you're looking for some learning resources, these are some of the resources you can refer. Next, for the remaining vulnerabilities, I have added bonus slides at the end of this, so you can go through that. That's it. Thanks, everyone. You can get the talk materials and you can connect with me at the following link, linkhq.co/Adarsh. Thank you.